Hello friends, this is Suresh and today we will go through ResNet and how to fine tune pre-trained Resonant module and how to fine tune we will take example of image classification. So before we start the demo and the code, so I will go brief about the ResNets and what is the best practice toward the net ResNet. So in deep learning, in machine learning, if we will go in the deeper of the network, then we will found that problem gradient will die and learning stopped. So here that called training error. Here is a iteration, like one iteration, two iteration, three iteration. So in and this is graph for one graph for 56 layer and one graph for 20 layer. So there are two layers. So we are we looking here like 56 of layer, and if iteration increasing, so here training error also training error also increasing. So lower layer training error is lower, and higher layer training error is increasing. So training error should decrease, but here training error increasing. So what we have to do for that? So for that problem solved by the Resonant. So training error should not increase if we go deeper in the network. So that called the Resonant. So right now I'm talking about the what is the Resonant. So in core idea of the Resonant is like it's introducing that called identity shortcut connections. So here you look that this is the one layer of deep neural networks, and we are connecting as a shortcut connection. So we are just passing whatever input, just a shortcut connection to the layer, and that called like fx plus x. So we here whatever input, whatever output of that layer we are getting, so we are updating with the shortcut connections. So that one block called residual block. So this will solve the problem of if we go deeper in the network, and like vanishing gradient problems, such kind of problem it will solve, and you will get better results. So another example, like how different kind of variants of that residual blocks that resonate. So the kind of like where we are adding that shortcut connection. So this is the shortcut connections, and this is the layer. So shortcut connection, so we are for example, these are the original, and this batch normalization we are adding after addition. So here we are adding shortcut connection, and that batch normalization we are adding after shortcut connection, and ReLU before the shortcut connection. So this is ReLU function we are with the shortcut connection, and ReLU only the activations. And so this kind of the variant generally people are using for that for especially in different kind of variant of resonance. So and this is the another example of the Resonant XT. So like multiple, if we like this is one layer, and this is second layer, this is third layer, and we can say like total path of 32. So and we just add the shortcut connection, all of this, all of combination of this output. So the 256 of D out. So this all about the this is one called the residual block. So this is one residual block. So this is all about the basic fundamental about the residual blocks and how residual blocks working. So I will not go more about theoretical of the Resonant. So I already post a tutorial especially for the Resonant. So now I will go through that tutorial about code. So right now today, yeah. So this is example I will show how like transformer learning for especially computer vision use case, and we are using the Resonant here. So and you heard about the transfer learning. So transfer learning, generally lot of way we can use the transfer learning. So especially the keyword used transfer learning. Transfer learning, like we are transfer whatever we already, like whatever we have. So for example, a model trained with 1000 images, right, and 1000 class, and we want to train in new things like add some new classes. So for example, you trained a model with the image classification, like images, cat image, dog image, and other kind of animal images, and that you trained a model. Now you want to add few more class also, like only, uh, and another example you can take, like you want to, apart from 1000 class, you want to use only two class only. So like cat and dog only. So what you have to do that, So you fine tune that network, so that to call the transfer learning. So there are two way to do that fine tune. So like we can use initialize the pre-trained network weight, and another like we can use pre-trained network and modify, and the final that final layer, like that called final fully connected layer, we have to modify that. So there are two way we will do in this demo. So I will show the demo. We will use here PyTorch. So PyTorch.nn for the, especially for neural network. This is for optimizers. This is for learning rate scheduler, and this is for vision library, and this is kind of all the data set and transformation of the image, all things. So first we have to download the dataset. So dataset is, I will explain just dataset. So dataset is the contain the images of bee and ant, bee and makhi and ant cheetah. So cheetah and makhi. So this is all the dataset of bee and ant, and we just import the dataset, and using the dataset loader we download using this command, like wget. We can download the dataset and unzip the dataset, and there are two things for training. So we split the dataset in there already splitted dataset, training and validation dataset. So there are two things in particular folder, training and validation. So just that is the image dataset, and we convert is a PyTorch data loader. So this is the data loader, and there are two class ant and bee. I will show that dataset here also. Like you will see the ant and bee images. So here I plot around 24 images. So you will see here 24 images grid. If I reduce the number of images here, so I can reduce the number of images here also. How many images I have to take as a base size. So here like 24 images I can take as a 4. Like I want to take only 4 images only, so I can take that 4 image, and I can show you only the 4 images. So you can see the bee and ant images here, and again I will take 24 images, so it will show the 24 images. So this is the 24 images, it will show the 24 images. One thing I have to talk about, like this is we start running with GPU or CPU. So I will use GPU here. So I will set a device, like if GPU is available, if CUDA is available, so training will run in GPU. If not available, training will run in CPU. So that's, and this is for function for writing a function for training. So in training, like how many epochs we have to use, a number of epochs it will run, and input we have to passings and learning rate, everything, and yeah. So this all about the training function, and this is for function for visualizations after training. So after train the model, we have to visualize what happened, how model right now working with test data. Yeah. So here I want to focus on like how we can use a pre-trained Resonant network. So this line, the cell number 15 in this line is most important here. So we just import models.resonate. So that models function, this models we are getting from the PyTorch. So PyTorch library, and in PyTorch library Resonant 18 we are using here. So Resonant 18, and we passing here pre-trained is equal to true. That means like we use pre-trained model. So we are getting the pre-trained models here. So the first way I talk about, like we in the pre-trained models we initialize the whatever weight pre-trained weighter we have, and we have to change number of the classes of output. So there here in our use case we have two class only, bee and ant, yani makhi and cheetah. So we want to classify the image ki this image makhi and this image cheetah. So that call ant and bee. So only two class here. So so output is the two input. So whatever the fully connected layer will take the input of the from the previous layer. So how many number of the filter is there, that call the as an input. So this is the input, and we are updating the final fully connected layer here. So this is the main change for the transfer learning here. So we are just we train the model again only for the two classes only, and we, so here we change here as a output class only the two here. So this is the main things, and I will run it. again like data nn dot data dot parallel. So I use for like how training, if I use the compute resources like GPU, so how many GPUs available, and I want to run the training all the GPUs. So in my case I have 3 GPUs, so GPU 1, GPU 2, GPU 3. I want to train the model on all the 3 GPU. So then I have to that PyTorch function is there like nn dot data parallel. So this is the data parallel function, and this is used for parallelize the training as a like. So just we have to pass the model whatever we have in data parallel function, and we are getting that, and then we have to set device as a like whatever GPU device or CPU device we have to select. So if we are using the training especially on GPU, then we have to pass as a GPU device here. So this is the main part for like how to start the training across the multiple GPUs. So I will explain, like I will show how that multiple GPUs. So here that loss function we are using cross entropy loss functions, and optimizer we are using SGD like stochastic gradient descent optimizers, and learning rate, this is learning rate, and momentum, yeah, 0.9. And learning rate we schedule as a like internally that module of LL scheduler, the learning rate scheduler of PyTorch. So we'll use that. And right now I here starting the training. So the number of epochs means here 2, so I will change it to 10. Sorry, 10, I will change it to 10. So I start the training here. So I start the training here, or you will see here like GPU are using right now. So 80%, 30%. So all of the 3 GPU are using here. 1, 2, 3. You all you. I think that's the visible. So all the GPUs computationally. So right now like training converges fast. So you look here like epoch per time 2.3 sec 36 2.73 seconds per epoch time. So around 2 seconds, we are getting the times for all things. And another example I will show here, if you are not use that data dot parallel, so I will comment it, and I will run it again, and we'll see the results again. So again I will run it. So here you will see here only the one GPU right now using, only not 2 GPU are not using, only one GPU the training using. And you will see the results also here, like per epoch is taking 3.5 and 3.5 3.6. So previously we are getting 2.5 around. So here every epoch 1 second increasing for training. So for the saving the time, we can use all the whatever GPU resources we are using here. So that is the how to we can load the load the training, how to distribute the training with across the multiple GPU. So that's example I will show you. And this is the visualization all of the. So we can see how the result going on. So you can see here this all the ant image. So you will find the ant here. This is the B image. So you will, so this is the result of classification. So this I completed training, and training accuracy called the 96%. After training I have to check like how my model working on. So model work is good or not. So I have to visualize with test data. So test data I pass some images, I'm checking is working correctly or not. I'm checking here like this is the ant, so it's called ant, and this called ant, and this is B image. So right now it's classified well. So image also B, and it's predicted also B. So prediction and actual image also same. So my model working 96%. Another way of the I already told about that we can do many way for transfer learning, but yeah, I will show you another way also. So in another way, like previously we change only final layer as a output only, and we initialize the pre-trained weight here. But in this way, like we don't want to update all the networks. We want to only update final layer, like, and the fully connected layer weights only, right? So here like if you don't want to use complete layer weight, so we just pass here like required grade is equal to false. So if required grade is equal to false, so it will freeze the all previous weight, and we initialize with like final layer, and final layer output like number of class, number here how many number of class here is 2, and this is all. So I think here in PyTorch you no need to do more things, only you have to do only the param dot grade it underscore grade equal to false, so it will freeze the other uh, weights also. So other weight not in not updating, only update only final a fully connected layer weights only, and it will train the model. So I will show here this results also. So here you can see it will use the multiple GPU, single GPU. So use single GPU because I enable only uh, that models, and you can see this result also. Yeah. So this is B, this is AND. So this is actual में B, and this is AND. So it's classified right now that image particularly. Or this is called B, this is AND, right? Yeah. So this is all about ResNet. So this is the main purpose of this tutorial, like how to we can use the ResNet, and how can you pretend network, how can do transfer learning, so all thing about it. So this is all about it. Yeah. So thank you for joining the meetup. Thank you all.